Hello everyone. This is a mini-art, the first of its series to help you use Excel. And this is specifically aimed at creating equations in Excel. Now this is a data sheet that is not dissimilar to your Greenland data sheet, only this is for the Antarctica. This is for Antarctica. And indeed this is part of an Antarctic data sheet. The first thing you do when you open a spreadsheet is you look at the information at the top. So you're looking at the column titles. If there are row titles, you're looking at any text there is up here. This is all very important, and you should read that and have a look at the data and understand what the data are about and how they're displayed before you start playing with them. Sorry, I mean analysing. I just love it so much. I think of it as playing. Now, here we have depth in metres for this G4 ice core, mainly G4. And here we have ice age in years and gas age in years, nothing in those columns, in those rows rather. Delta deuterium per mil, which is French for per thousand. This is the measurement of delta deuterium. Now, just to get some idea of how much data there are here, then if I go all the way down, keep going, I can go down to forever. There's quite a few rows in this spreadsheet. Okay, oops. And look, 3,316 rows, and you'll notice that now all four columns are occupied. So the gas age comes in at, there you go, it comes in at 98 metres below the surface, right? And there is a discrepancy between gas age and ice age in this ice core. You might want to think about why. Okay, it's not a mistake, it is the case. Now, to return to our equation. Okay, we've got, 3,600 rows, but we've actually only got 4 columns of data, so it's quite small really. And what we're going to do is we're going to create another column, which is going to be, I'm going to call temperature calc. Temp calc. Okay. And in here, I'm going to use this delta deuterium equation that I've already rearranged for you in your tutorial information sheet. So we're trying to find out the temperature in negative degrees C. And so what I have to do is I have to type in here, it's quite straightforward actually, equals, which tells Excel that this is going to be an equation, anything that follows equals, minus 55.5 plus open bracket. Now you don't type delta deuterium in there, you actually want that number in, so just click on the cell with the number, which is D6, and check that's right, yes, and then it's D6, so delta deuterium plus 440 close bracket divided by 6, which is exactly the same as this equation here, only instead of delta deuterium you've got that cell reference because that is the delta deuterium next to this cell, and I press return and I get minus 55.17 degrees centigrade. Now, shall we just use Command C and go down to a different number? How about 447 here, and do Command V, that's copy and paste. And if I look in here, look, it's the same equation, only instead of D6 it's got D31, which is this cell 1 to the left of where the equation is here, right, this cell here, which is D31. Now that's a good thing about Excel, unless you tell it otherwise. Then when you put cell references in, the address is D for the row and D for the column, 31 for the row. Then whenever you move that equation, it will move the cell address so that it stays at the same relationship to the destination cell for your equation. Hence we had D6 back here because it was one cell in the column to the left of E6, and that becomes D31 here, one cell to the left of the column E, the same row, which is 31, yeah? And it doesn't matter wherever we move this to, it will keep up that relationship D19, right? That means that when you've created an equation, you can just go Control-C and you can copy it either by doing that, highlighting, and Control-V, copy and paste, sorry, Command. I am a PC user at heart, as you can tell. Or alternatively, you can just highlight the cell with the equation and then click on that little thingy to get hold of it and pull it down. And you can go as far as you want. Now, I'm not going to go all the way down because it will take some time and it will upset my computer. But what I always suggest you do is every now and again you just check to make sure that it is working. So you'd go down the column and pick out 3 or 4, just click 3 or 4 cells and look, D34, D34. So that's quite correct. So it's maintaining that relative reference. Now, that means that if I copy this cell to here, Control-C, and put it in here, it should have maintained that one cell to the left of me in the row to the left of me, i.e. me being the destination cell where you've got the equation. And sure enough it has, because look, it says B7, which is this one here, right? So wherever you move this equation, it will keep up this relative one cell to the left, in the column to the left. Look, B27, and sure enough, B27. Okay. Now I'm just going to get rid of that one, right, by using that famous Command Z. I tell you, these shortcuts really make life more easy. Now, to go back to the original equation, what happens if I want to move that, but I want to keep the reference to this number? Well, in that case, I have to make it an absolute reference by putting $, in front of both parts of the address and just press return. It doesn't change that equation, but now if I Command-C and put it in here and do Command-V, you won't notice much difference, okay, because it's the same number. But look, it's still D6, and if you click on here on the equation, it will highlight that cell, and look, it's still referencing here. And again, if I put it in there, oh no, sorry, never do that when you've got the cell highlighted. Just press escape. That does not do any damage. Okay, so if I go back up to here and do Command-C again, and I'll go further down and go Command-V, then sure enough it's kept D6, and if I click on here again, still referencing that cell, yet we're down here. And so that's why that number, the outcome of that equation product is 55.1667, like it is up here. It shouldn't be that, of course, because if I go back to my original copied equation, it should be referencing D31, which is here, and that means it should be minus 56.78 degrees. Okay, so I'm going to go back up to here, and I'm going to now copy that and take it over here, and sure enough it's still keeping that reference to D6. So it doesn't matter wherever I move that equation in the spreadsheet, it will still keep that reference to D6. Now that's extremely important to be able to do this. Right, so I'm going to delete that and go back up here. Now, as you've noticed, I had to put $2 prompts in, and that's because there are two parts to a cell reference. There's the column and the row. Now, sometimes you only want one of those making absolute. So, for instance, if I just take that $, prompt away, that effectively means that this equation is telling the computer that wherever this equation is, the computer has got to use one column to the left of it, row number 6. So shall we just test that by Control-C, put it down here, sorry, Command. And sure enough, it's still got that D6, but it will if we move it to over here, it's still kept that row 6, but now it's using the column 1 to the left of where the equation is. I'll highlight it for you. But row number 6. Can you see B6? So in other words, we've allowed the column to be relative, i.e. one column to the left, but we fixed as an absolute row number 6. Okay. Now this is extremely, I'm going to do Command Z, which is undo. Command Z, undo. Command Z, undo. See how useful that is? And I'm going to undo again to get back to D6, and I'm going to get rid of those spurious data. There you go. So now I'm back to D6 relative addressing, because that's all I need. So we've gotten the temperature calculated, which is in this column, and take it all the way to the bottom. And you now understand the difference between relative and absolute cell addressing and why they're extremely powerful tools in Excel. And I'm going to finish it here, and in the next minute I'll be looking at graphs.